Okay, today we're going to divide polynomials, which we will learn to do in just a minute. Let's start with old school with just long division. If you remember elementary school, which number goes in the house? 13 goes in the house, 5. You're dividing by 5. 5 goes into 13. Well, it goes into 1 no times, goes into 13 2 times. Try to keep things organized, put it in the ones column there. So I get 10. Remember you always subtract this number, right? And in this case, you get 3. Um, and so I don't know if you remember the days when we used to stop. I know we could keep going at a decimal, but that 3 was called the remainder. Right? We just kind of stop there. That's the remainder. And if you remember what these other 3 numbers are, maybe you know that the divisor is what we divide by. So that would be the 5. The quotient is kind of our answer, which is 2. The dividend is the number we're dividing by something. So that's the dividend. So I say all that to say, I want your answer written in this form. I want your answer written in the form of quotient plus remainder divided by divisor. So for this problem, the answer would be 2 plus the remainder, which is 3 divided by 5. In other words, 2 and 6/10, 2.6 is the actual answer. But I want the answer written in this form, which is going to look a little different with polynomial division, but that's the answer. Definitely write this down. Quotient plus remainder divided by divisor. Quotient, what you get. Remainder, you're going to have a remainder sometimes. We're going to do that. So let's do long division. So similar kind of thing. These are grouping symbols, so we're dividing those. I'm going to try to keep things real organized when I do this. So x cubed plus 4x squared minus 3x plus 2 goes in the house. X minus 1 is what we're dividing by. That's our divisor. So like for the first thing here, we're looking at x, the first term of each. So just the first term. So x times what is x cubed? And that would be x squared. And so I'm going to put x squared in the x squared column. So I'm going to put it above the other x squared terms here. Now that gets multiplied by both terms and I put it down below. So x squared times x is x to the third. It's no surprise it matches that first term. X squared times negative 1 is minus x squared, or minus 1x squared. Okay, so we're going to, just like we did before, if you remember what we did here, we subtracted the number there in that row. So we're going to subtract everything in this row here. So I'm going to subtract. So you don't have to do this, but I typically like to just distribute the negative. So I'm going to put plus, negative, and plus here. So when you do that, the x cubed goes away. 4x squared plus 1x squared is 5x squared. Do you remember this? You bring down the next term, so minus 3x. And now again, you're looking at the very first term here. So we're looking at x and 5x squared. X times what is 5x squared? Well, that would be 5x. So I'm going to say plus, not just 5x, but plus 5x. That's a positive 5x. I put it in the x column there. That gets multiplied by both of these terms over here, so both the x and the negative 1, so 5x squared minus 5x. Negative 1 times 5x is that. And we're going to subtract both of those terms. Don't forget to distribute there. So I'm going to distribute the negative, and let's see what we get here. So the first term should go away. It does. Negative 3x plus 5x is positive 2x. And then bring down the next term, so plus 2. Now we're looking for what goes into that last term. So x times what is 2x? So x times 2, so it's a positive 2, so I would say plus 2. It's going to be 2x minus 2. I'm kind of hopeful this goes away, but we'll see what happens here. So everything there is being subtracted. I like to go ahead and distribute the negative there. So I'm going to put this plus minus and plus, and the 2x goes away, but unfortunately the 2's add up to be a remainder of 4. So that's a remainder down there. This is our quotient up here. So our answer is going to be our quotient, x squared plus 5x plus 2, plus a fraction, our remainder of 4, divided by our divisor of x minus 1. And that's our answer if we divide those two polynomials. There is a remainder, which means this x minus 1 is not a factor. If the remainder was 0 here, it would be a factor, but it's not. So it does not divide nicely into that polynomial. Let's try this one. So again, just kind of set it up. It looks a little different with the division sign there, but it's pretty much the same kind of problem here. So we get 8x cubed plus 6x squared minus 29x plus 15. And we're divided by 4x minus 3. So you want to look at that very first term there, and you're going 4x times what is 8x cubed? So that would be 2x squared. So I'm going to put that in the x squared column. So 2x squared in the x squared column. I'm trying to keep my work very organized when I do this. So that first term matches. That pretty much always happens. 2x squared times negative 3 is minus 6x squared. I'm going to subtract both of those guys. Distribute the negative here, so this becomes a positive, a negative, a positive. There's a positive now. So I get 12, the first term goes away, 12x squared. Bring down the next term, minus 29x. Now we're looking at the second term there. I mean, we're looking at the first term of this row. So 4x times what is 12x squared? That would be times 3x. So plus 3x is a positive 3x, so it's plus 12x squared. Negative 3 times 3x is minus 9x. We're going to subtract that guy. Distribute the negative. And you get negative 20x. Bring down the next term, plus 15. Okay, we're getting there. I'm almost done because I'm almost done up top, so I know I don't have a constant left if there's anything here. So 4x times what is negative 20x? That would be times negative 5, so I'm going to say minus 5 up here. You get negative 20x. Negative times negative is positive, so that's plus 15. I'm very hopeful this is going to go away. Let's see what happens here. So I'm going to subtract both those guys. I'm going to distribute the negative. And both those end up being 0. So my remainder is 0, which means this is a factor, right? So my answer is 2x squared plus 3x minus 5. That's my answer. If I were, and this is not part of the question, but if I were to multiply this times this, guess what I would get? Do you have a guess? So they are factors. So this is a factor because remainder is 0. This is a factor. So you multiply, you would get this result, this polynomial right there. So this is really the purpose of why we're learning long division polynomials. Sneakily, we're going to kind of use this to factor some polynomials. So we'll use this to kind of factor some things that we might not have been able to factor before. So this is a really good problem. Let's try this one and see what happens here. So 3x to the 6th minus 10x to the 4th plus 7x squared minus 12. I think this is going to work. Normally, I'd be really concerned about the missing terms there, but because this, if you remember back to even, this is an even polynomial and this is an even polynomial. They're both even. Neither of them have odd terms, x to the first, x to the third, x to the fifth. So I don't think we have to put those in this particular case. You'll see in a minute, sometimes we really have to be concerned about that. So x squared times what is 3x to the 6th? So that would be 3x to the 4th. So I'll put that in the x to the 4th column. So we get 3x to the 6th minus 9x to the 4th. Going to subtract both those guys. Be sure to distribute the negative. So this ends up being negative x to the 4th, bring down the next term, plus 7x squared. And now we get the second one here. So x squared times what is negative x to the 4th? That would be minus or negative x squared. So minus x squared. Negative x to the 4th matches. Plus negative 3 times negative x squared is positive 3x squared. You're going to subtract both those guys. So we get negative, that becomes positive, that becomes negative. So we get 4x squared minus 12. And last one here, so let's try to get this. X squared times what is 4x squared? That would be plus 4. I know I'm done up there because I've got to my constant there. This should go away there. Negative 12. Ooh, this is good. So I'm going to subtract both these. When you do that, you'll see that this distributes, that becomes negative. Those both add up to 0, so my remainder is 0. So again, for the second time in a row, we have a factor. So 3x to the 4th minus x squared plus 4 is a factor of this polynomial. If I multiply it by this guy, it would multiply to make that 3x to the 6th polynomial. Okay, so organize our work by descending order of degree, especially when we have, like we're dividing by, this has both even and odd terms in there. So this is going to be very important. So let's try this and get this right if we can. So we start, we go 8x to the 4th, nothing's funny, plus, it doesn't seem to have an x to the 3rd term. We'll come back to that. So plus 6x squared minus 31x plus 1. So really we need a term in there. So we need a 0x to the 3rd term. Because it's missing, it's kind of like right here. Shouldn't there be a term right there, like between the x to the 4th and x squared? It's missing the x to the 3rd term. We don't really have one, right? So I put in a 0x cubed. So this is an important step to do when you're missing a term. You want to keep the order, the degree order complete there. So you don't want any missing terms. It'll kind of mess up your subtraction when you do this. And by the way, this time we're dividing by a polynomial, so a trinomial, in fact. So it's going to be a touch harder. Let's see what happens. That should be fun. So we look at this, we go, okay, 2x squared times what is 8x to the 4th? So that would be 4x squared. So to put that in the x squared column, because it's right above the x squared there. The first term is going to match 8x to the 4th minus 4x cubed plus 8x squared. I'm going to subtract all those guys. So I get negative, positive, negative. Okay, so I'm adding 0x cubed plus 4x cubed. It's 4x cubed. So this is where it really comes in handy to have that x cubed column, because otherwise I might mistakenly add up the x squared with the x cubed or something. Minus 2x squared. Bring down the next term, minus 31x. Let's look at the next one. So we get 2x squared times what is 4x cubed, so that would be plus 2x. So 4x cubed minus 2x squared. Sorry, this is a squared term. I don't know why I had a cubed there. It helps me. I know it's in the squared column, so I know it's a squared term. Plus 4x. I'm going to subtract everything there, which means I'll probably have to distribute the negative here. So let's distribute that. So this is nice. The 4x cubed goes away. The 2x squared goes away. This becomes negative 35, this is not what I expected, negative 35x plus, bring down the 1, so plus 1. And if I try to do this, 2x squared times what is negative 35x? There's really no other term up there. We're done up there. There's no 2x squared times. I'm not going to put a negative exponent up there. Constant would be the smallest I get. So this technically is my remainder. So my answer is 4x squared plus 2x, which is the quotient, plus the remainder, negative 35x plus 1, divided by the divisor, which is 2x squared minus x plus 2. So that's my answer, and that is not a factor, right? We tried to divide it. It did not divide nicely. Okay, so working backwards, given a polynomial in standard form, so if those are the solutions, the factors, and you're probably to the point that this isn't too bad a thing, the factors would be what? X minus 2, x plus 2, and x minus 3. So it's always like, the factor is always like x minus the 0 or the solution. It's the factor there. Because we want to write a polynomial, I'm going to write it as y equals, or you could write f of x equals would be fine as well. And then we're going to FOIL this out because we want a polynomial in standard form. This is not standard form. It is well, kind of a polynomial. It's just not the right form. So we're going to have to FOIL this guy together. Let's do that. So we get x squared minus 4 when you do difference of squares there. And then FOIL that with the x minus 3. And we get x to the third minus 3x squared minus 4x plus 12. So that is one possible polynomial. It's not the only polynomial that has those solutions. We could put a coefficient in front there, like a 2 in front of the whole thing. A 2 right there would also be a 3 right there, or any number multiplier would still make this work. But that's a polynomial. That's how to work backwards. It's always just x minus the solution. So if your solution is 2, your factor is x minus 2, and you just multiply it out. Okay, so now we're to synthetic division. Again, getting back to what we just did, if the solutions are at 2 and negative 3, the factors are plus 3 and minus 2, right? And if you, I don't know, I just want to make sure you make this connection because it might help us. So let's say we plug 2 into this function, f of 2. If you look at that ordered pair, you might know the result, but if you don't, that's okay. So this would be 2 minus 2 times 2 plus 3, which is 0 times 5, which is 0. Well, that's interesting. We plugged 2 in and we got 0 as the result because that's called, remember this point is called a 0 of the polynomial, or a solution of the polynomial is 2. If you plugged in negative 3 in this one, I wonder what you'd get. Let's see, let's plug in negative 3 and see what we get. So we get negative 3 minus 2 times negative 3 plus 3, which is negative 5 times 0, which is 0. So we get, oh, interesting. So we get 0. So when you plug a solution in, we get 0 as our result, or in what we're about to do, we're going to get 0 as our remainder. When you plug in a solution that works, so we're plugging solutions into the problem. The solution, and we're trying to get a remainder of 0, which would be a result of 0, which you might see in a minute. So this is called synthetic division. It is a purely American method. They don't use this in other countries that I know of. I have friends from other countries who teach math and they don't know what this is. So you put the solution in here, or the potential solution. So remember the factor is x minus 2. So if the solution is there, the solution would be positive 2. So x, think of this as x minus c, or minus a. Sometimes we use a for that. And the a value goes in there. So that's a. So if this is kind of a linear factor, it's just nice and linear there, you can use this shortcut. So you can't use this shortcut on this problem. See how we're dividing by quadratic there? Can't use it. But synthetic division works when, oh, this is just straight up linear there. You can definitely use it on this. So what you do is you take the coefficients now of this term. So the coefficients are, there's a 1 there, implied 1. So 1, -3, just kind of space them out, 5, and -4. So the negatives go with that. To do synthetic division, it actually goes pretty quickly, but it does this. So you bring the first term down. It's just 1. You're adding terms there. So 1 plus nothing is 1. Now you basically take this term times this term and you put it here. So this will make sense in a second when you see a few iterations of this. So 2 times 1 is 2. Remember, we're adding now. So -3 plus 2 is -1. Now we take this term times this term and put it here. You'll see this pattern. It'll make sense in a second here. So 2 times -1 is -2. Now I'm going to add vertically, so that's a 3. And now you take this term and this term, and you put it here, and you multiply it, and you put it here. So this would be 2 times 3 is 6, which is a positive 2. Always draw a line after you get that last digit. That is your remainder. You want to separate it from your problem. I just want to show you kind of what we're actually doing, because you may not look at the answer and go, well, what kind of answer is that? Let's work this the old-fashioned way. So I'm going to try to do this one somewhat quickly, the old-fashioned. Okay, so I just did long division. I showed my work, but this is the result. Well, one thing that's interesting, the remainder is the same. Well, that's interesting, isn't it? Look at our quotient. I don't know if you find a correlation here. So I have 1 as my first coefficient, -1, and 3. 1, -1, and 3 are my coefficients. Oh my goodness, we get the same answer. So working backwards with synthetic division, this is our constant, this is our x term, and this is our x squared term. It kind of goes backwards. So remainder is always on the right, then we have our constant, then our x term, then x squared. If there was another term, it'd be x cubed. It's going to keep growing by x's, one x at a time. So our quotient would be x squared minus x plus 3, because that's positive, plus a remainder of 2 divided by our divisor, which is x minus 2. That's actually my answer there. So synthetic division, once you learn how to do it, actually goes very quickly. So let's try one here. So, but degree should be very orderly. I wonder what that means. Okay, so let's put this in the box here, draw our thing. So careful, our factor is x minus 1, so our potential solution is a -1. That's very important there. Just take your coefficients of this, what you're divided by. So coefficients of this would be 5, 1, skipping 1, 2. Do you see the missing term there? I hope you see it. We're missing an x squared term, right? We don't know what x squared is, so we're going to put a 0 in there because actually there is 0 x squared. There's no, so 4th degree, 3rd degree, 2nd degree, 1st degree constant, which is 0 degree. So don't forget to put that 0 in there. It's going to be crucial. You'll get it wrong if you don't put the zeros in there when you're doing synthetic division. So you have to have that 0 in there. So you add it up vertically. We're adding vertically. 5 plus nothing is 5. -1 times 5 is -5. 1 and -5 is -4. That's a positive 4. Add it up. 4, that's -4. I get positive 2. I get -2. I get 0. Remainder. Which means I found a factor. And so this is going to be the constant. This is the x term. This is the x squared term. This is the x to the 3rd term. So my answer would be, my quotient is 5x cubed minus 4x squared plus 4x plus 2. And that is a factor. Along with this is a factor. If we multiplied those, we would get that result over there. Okay, so there's a couple more things where there's a lot to lesson. The remainder theorem is basically this. So if you plug this in the old-fashioned way, so if I do f of -1, we've done this before. So you get 2 times -1 squared minus 3 times -1. So sorry, this 1 plus 1. So this is 2 times 1 is 2 plus 3 plus 1, which is 6. So my answer, f of -1, is 6. So oftentimes they'll say, use synthetic division. The question may say something, use synthetic substitution. Synthetic substitution, they'll call this, to find f of -1. So they might phrase it something like that. Find f of -1. Well, if your solution that you're checking is -1, your factor is x plus 1. I don't know if that makes sense, but that's the old solution factor kind of working backwards thing we talked about a minute ago. So, but in the box, if I'm doing synthetic division, which is called synthetic substitution in this case, -1 goes in the box because the factor is x plus 1. The solution, the potential solution is -1. Same problem, so we're going to put the coefficients there, 2, -3, and 1. This should be easy to do. Add them vertically. You get -2, -5, -6, sorry, -6. Is that right? I'm sorry. You're adding, not multiplying, -5. -5 times -1 is +5, which is 6, which is our remainder. Even though I just made a mistake, usually it's a lot more foolproof to do synthetic division. This causes lots of issues, especially like stuff like this. Students will multiply inside and then square. They'll do the order of operations wrong. They won't use parentheses correctly. It's really easy to make a mistake and not get the right answer of 6 there. Here, it's a little bit more foolproof, and you get a result of 6. So the answer, what's weird is, what is f of -1? F of -1 is equal to 6. So the answer is our remainder. That's why this is called the remainder theorem. So instead of doing it this way, you could always check your work that way if you want to, but we're going to actually solve these kinds of problems just doing synthetic division because it's faster to do that. Okay, let's try one this way. So you might want to do it off to the side. Just do g of -3 over here the old-fashioned way. But I'm going to do it this way. I'm going to put -3 here. I think this is more foolproof. I think it's easier. 1, 3, -2, -6. Just do your stuff. So -3, 0, 0, -2, +6. Oh, I love this. So my remainder is 0, which means I found a factor, right? That's huge. And I know what my factor is, right? This is going to be x. This is going to be x squared. You've got your factor. Your answer is x squared minus 2 if they asked for what is the other factor. If they said what is f of -3, or g of -3 in this case, since it's the g function, the answer is 0, right? That's our remainder is our answer. If we actually plugged that in and worked it out, like -3 to the third plus 3 times -3 squared minus 2 times -3 minus 6. So this would be -27 plus 27, that's weird, plus 6 minus 6, which is 0. So you get the same answer. Again, your answer, if they're doing this kind of, what is g of -3? Your answer is going to be the remainder if you are using the remainder theorem and using synthetic substitution. Make sure when you do this with synthetic substitution, the big key in this problem, I hope you see it, is at 1, 0, -14, 5, and -3. The key is you're missing an x cubed term there. So don't forget to put that 0 in there. If you do this, -4, 16, which is 2, -8, -3, 12, 9. So my remainder is 9. So what is p of -4? If they ask that, the answer is 9. Our remainder is our answer. Last thing, just working backwards again, just to make sure you're getting this. I know it's a longer screencast than normal. There's a lot going on here. So there are 3 solutions. So your 3 factors would be x minus 2, x plus 2, and just straight up x, right? Because that's just x minus 0 squared, essentially. So if you FOIL that first 2 together, you get x squared minus 4 times x, distribute the x, you get x cubed minus 4x would be one function that has this look to it. That we don't really know where those points are, up there or over here or over here. We don't know where those points are, so that's one function that definitely does have those solutions. If we knew those exact other points, we might be able to, figure out what the a value in front of this function is. But that's one function that has those roots, which is what the question asked for. That's your lesson.